you can so let's just deal with this, and then I'll continue to the pointer and we'll look at the different return types. But basically, I have this class. This class has two methods. All right. So um in this case, my first scenario here is that I'm returning by reference, right? So this function increment value is returning by reference. Now, the idea in chaining is that you can call a function multiple times, right? In a chain, or you can create a sequence. So this is where the this pointer is implied, right? This pointer. Now, this here, it's a pointer. If you create a class, right, it's like implicitly every function in the class, right, every function in the class would have, if you, let's say, put a print statement to say what is this, right, it will give you the address of the object that you instantiate for that class, right, in all the functions. So f1, f2, right, within it you can call, you can just do a print cout for address and have this, and it will give you the address of this object here. Okay, now we're using that to create chain functions. Like you see here, I have the first function I have is increment value. The second function is display. So in this case, we instantiate a class, right? And it's called object, and we are gonna we are utilizing um, we are utilizing increment value, this function here. In this scenario, it's by reference. All right, so if it's by reference, so you will have object dot increment, because it's an object, is on the stack. You call the first function. This function here is returning a reference, so you're getting back to the object. So that is why I use the dot notation here. All right, now if we flip this around, all right, let's go to the actual code here now, right? If we just highlight this and get this commented out and get this on, comment out this. All right, so in this scenario here now, file, save, we are using the, we have the same instance of a class, and this function is returning the this keyword here, but as a pointer. You see here we have just this. Initially we had asterisk this. Now this here is by reference, right? Because this gonna become this. So you're dereferencing something. So this is returning the object by reference. This here is returning by pointer, right? So here you start out the same way, object dot increment value, because this is object is on the stack. You call the first function, But the first function here now, it's returning by reference, by by pointer. So now you have a pointer to this object. So let's say this is your object. So at this point here, you have a pointer to that object, right? So whatever is, let's say this, the address of the pointer is here. So now you can access the display method within that object, and you can call that, and that's how you're gonna um, you can chain these functions. Now let's run the code for this so you see what's happening here. So I hope I'm in the right path. Okay, so this function here is g++ std equals c++ 2a dash o, and this is object return, right? Well, I have pointer versus reference, right? Because we're showing two techniques here: pointer vs ref, and the object it's not gonna go through .cpp. Just bear with me here. It's a bit slow, but we just want to run this code so that you can see that the value that we get out of this is 10, because we are sending it. Okay, so now let me just run this code. Object return. Good. So you see, in this case here, I have 10, and how I'm getting 10 is that, let's try to explain that. So we are calling this function increment value and passing in 10. The 10 goes here. So this here translates to this value equal this value plus whatever is coming in, increment. Now, because this is a default constructor, let's say this guy here is set to 0. So 0 plus 10 give us 10. 10 comes into this value, and we are returning not the value, we are returning the pointer, right, to the object, right? So that's why, well, the pointer to the object, so it comes in here. So we have the pointer to this class, right? And now we are going to the display function, right? So we have a pointer, and it's dereferencing or point to the display function, and it's really calling the display function. And this value here, right, is going to be this value here is going to be printed as 10, and that is how we are getting that 10 there. Now when we use return by reference, in this case here, right, when we pass in this 10 here, we have the same 10, but we have this here, this pointer. So I'm returning an actual object, the object itself, right? What I mean, I'm returning a reference to the object. So it's like the object, it's a reference, it's not the object itself. It's an alias, it's a reference to the object. So if I want to get some function in the object, let's say this is the object here and it has multiple functions. So you want to access something, you just get object dot that function, and that is why here from this point here you get dot display. Here, because you're returning a pointer, you have the arrow notation because you want to move through the functions within that instance of the class, right? So I want to show you the case now where I have here my class, which is an object, but what if I have a pointer, right? A pointer to the class. So let's look at that. So pointer return pointer here. So guys, you gotta bear with me a little. I'm trying to get this going. So okay, here you go. So now in this scenario, I have a pointer to the class. I'm creating an instance of the class here. So this pointer, so let's say we have this new class, right? This pointer, object PTR has an address 0 cross a, let's say 0 cross AE, whatever. It's this address of this whole class here, AE. Okay, so it's pointing here. So inside this class, this new class, you will have these functions: increment value and display. Now when I have object pointer with the arrow notation to increment value, I'm pointing to this. I am pointing here. So I'm passing a value of 10. 10 goes in here. I'm returning this by pointer. So I'm getting back a pointer, right? So now if I want to access this function, because I'm returning a pointer, I have to use the pointer notation here, this arrow here, to get to this function, to access this function or call this function. And this again gonna give me a value of 10. Okay, now we can run this. Sorry, let's get to the code. So in this case, I have C++ 2A, and I am doing a pointer return pointer versus a reference, and again PTR return PTR vs ref dot cpp. So guys, in this case here, PTR, let's see if it's gonna PTR vs ref. So see, I'm getting 10. All right, now I can do the same thing with this code here. I can have this part of the code commented out and have this part uncommented and comment this and don't comment this. File, save. Now in this scenario, in line 28, you see I'm starting out here with object pointer arrow notation, right, to increment value. Why arrow notation? It's because object pointer is a pointer to the class. Okay, it's not an instance of the class, just an actual object. It's a pointer. So when I call this increment value function here, in this case it's returning a reference. All right, so I think we discussed that, but we'll look at it back here again. Right, in this scenario here, when this function is called increment value, it goes here, this 10 does the set the value to 10. It's returning this pointer. I shouldn't say, well, yeah, this pointer here is going to translate to a dereference value. Right, it returns reference to the current object. So a reference, if I have an object here, let's say this is X and I have ref underscore X, I just call this X. I'm actually, if this is 10 and I change, pretty much if you change this value in here, this is gonna change, right? So it's just a different name for the same value, right? So I'm having the actual value reference here. So that is why when you want to access the display function, you have to use the dot notation because you have the object, right? You have the object by reference. So you want to call an instance, a function within this, let's see, f1, f2 is going to be object dot that function. In this case is display, so object dot display. So that's why you're having the dot here. Now the delete object pointers, because I created a raw pointer here, so you delete the pointer before you finish the, you terminate this whole function or this code. You delete the pointer and you set the pointer to a null pointer. Now you could have avoided this if you do, let me show you, smart pointer. The file is not displayed in the text editor. Oh, sorry, I should be on this one. Smart pointer, right hand side, close that screen. So the only difference here, if you go the smart pointer way, you have to include memory, right, for smart pointers. Here I just have IO stream, so here I have include memory, and you see here you have the unique pointer, and you make the new class. You don't have to use so return by pointer is here. Yeah, you don't have to use the delete and delete pointer and set pointer to null pointer. Unique, the smart pointer takes care of business for you here. So to recap everything that we have done here, right? um, if I can put it in brief here. So when you have a function, no, you have a class and you have an instance of a class. So we have a class A, and so we have an instance of class A. So object. All right. Now object, this class, let's say this class has functions f1, f2, and f3, right? And the return type right here, it's by pointer. So rt pointer, rt pointer, rt pointer. So the first, if I'm calling, if I want to call these functions, I want to chain them and call them, I will have object, right, dot, let's say I'm calling the first function f1, but f1 return type is by pointer. Okay, so to call f2, it will be f2 like this, the arrow notation here. And f2 return type is by pointer. So let's say I want to call f1 again. I can have f1, and then I want to call f3. I can have f3. All right. Now this same class, right? What if you had the functions f1, f2, f3, but their return type rt is by reference, right? So you would have object dot, for the first case f1, you call f1, but when you call f1, its return type is by reference. So you want to call, let's say, f2 now. So you would have a dot notation here, f2. And f2 return type is by reference. So let's say you want to call f1 again. You're going to get dot f1. All right? So when the return type is by reference, right? Give them a function. Let's say I have return type, right? I have the function here with a param, and when the return type is by reference, you have to use return asterisk this. When the return type is by pointer, you're going to use return this. Now we said that this pointer is implicitly passed to all the methods within the class. So in any given function within the class here, let's say in the body of the function, I have cout and I put this, and then I have this here. It's going to give me the address of this object in any one of the functions, right? So you're making use of this pointer, right, to do this kind of chaining of the functions. All right, so we covered, actually, from this here, if you see a dot notation here, what this tells you, it tells you that the function before, right, its return type was by reference. And if you see our pointer notation here, it tells you that this function before f2, that meaning f1, its return type was by pointer. So I think you can, if you go through this video, you get it, you would be able to understand function chaining and to see how these notations can change. Oh yeah, if we started out with a pointer, if when we have a class and if this was a pointer, my first scenario would be a pointer to the initial function, irrespective. Let's say this function is by pointer, then we will continue by pointer. But if this function is returning by reference, so my first instance would be a pointer to the function, it returns by reference, then you would have dot notation. Alright, so guys, I'll stop this video here.